Have you ever wondered if there's more to the universe than what we can see or touch? Could there be hidden dimensions beyond our perception? Well, sit tight and get ready for a ride as we delve into the concept of multiple dimensions. This topic may seem like it's lifted straight from the pages of a science fiction novel, but believe it or not, it's a serious subject of study in the field of physics. When we talk about dimensions, we're referring to the different directions in which we can measure or move. Picture a straight line. That's one dimension, length. Add a second line at a right angle to the first, and you've got two dimensions, length and width. Now, add a third line at a right angle to the previous two. You just stepped into the world of three dimensions, length, width, and height, the world we live in. But what if I told you there could be more? More than just length, width, height, and even time, which is often considered the fourth dimension. Enter the concept of multiple dimensions, the hypothetical dimensions beyond the four that we are familiar with. The idea might sound like a stretch, but we can't actually perceive these extra dimensions directly. Their existence is inferred from mathematical equations and physical observations. The thought of multiple dimensions opens up a whole new universe of possibilities. If these additional dimensions do exist, it could mean that the universe is far more intricate and fascinating than we ever imagined. Could they be the key to unlocking the mysteries of the universe, like the enigma that is dark matter and the riddle of dark energy? Could they potentially pave the way for time travel or space travel? The questions are endless, the possibilities limitless. So, delve into the mystery with me as we explore the fascinating world of multiple dimensions. Get ready to expand your mind and see the universe from a whole new perspective. Buckle up because we're just getting started. To grasp the concept of multiple dimensions, we first need to understand what a dimension is. A dimension, in simple terms, is a measurable extent of some sort. It's a way for us to quantify the world around us, and here in our everyday life, we are familiar with four dimensions, three of space and one of time. Let's start with the spatial dimensions. When you look at a book on your desk, you see its length, width, and height. These are the three spatial dimensions. Length is how tall or long something is, width is how wide it is, and height is how high it stands. For example, imagine a shoebox. Its length is its longest side, its width is the shorter side, and its height is the distance from the bottom to the top. Now let's consider time, often referred to as the fourth dimension. Time is a bit trickier to visualize because we can't see it or touch it like we can with a shoebox. But we all experience time as it flows from the past through the present and into the future. For instance, consider the time it takes for you to travel from your home to your workplace. That duration is a measure of the time dimension. So, in a nutshell, we live in a four-dimensional universe where every event, every object, and even we ourselves exist in a specific place at a specific time. But here's a thought. What if there were more dimensions than these four? What if our universe is much, much bigger than we can perceive? After all, 100 years ago, we didn't even know about galaxies outside our own, and now we know of billions. Now that we have a grasp on our perceivable dimensions, let's venture into the unknown, the realm of multiple dimensions. Multiple dimensions, as intriguing as they sound, are not a creation of science fiction. They derive from complex mathematical equations and physical observations. This may sound like a storyline from a blockbuster movie, but it's actually grounded in the world of modern theoretical physics. Let's delve into the scientific basis for multiple dimensions. They are not just random thoughts of imaginative scientists, but are based on two of the most talked about theories in physics, string theory and M theory. But what are these theories? Well, to keep it simple, they are theories that try to unify the four fundamental forces of nature: gravity, electromagnetism, and the strong and weak nuclear forces. String theory, for instance, postulates that the fundamental particles in the universe are not point-like but are one-dimensional strings. It proposes a mind-boggling 10 dimensions, the familiar 3 dimensions of space, 1 of time, and 6 extra dimensions compactified or hidden from our perception. M-theory, on the other hand, takes it a notch higher. It suggests that our universe is just one in a vast multiverse, each with different physical laws. M-theory, often referred to as the mother of all superstring theories, goes to suggest that there are 11 dimensions. These theories are like keys that could unlock the mysteries shrouding our universe. They could provide answers to questions like, what is dark matter? Or, what happened before the Big Bang? However, it's important to remember that these are just theories, and while they are based on sound mathematical principles, they are yet to be proven. The extra dimensions, if they exist, are believed to be incredibly tiny, curled up in Calabi-Yau spaces, a concept so abstract that it can only be described mathematically. While these theories are complex, they open up a whole new world of possibilities that challenge our understanding of the universe. So, let's continue our journey through the wondrous realms of theoretical physics, and who knows, we might discover a new dimension to our existence. The existence of multiple dimensions could revolutionize our understanding of the universe and reality as we know it. Imagine, if you will, a universe where our 3-dimensional world is only a tiny slice of a much grander multi-dimensional reality, an iceberg with the majority of its mass hidden beneath the surface. The implications of such a universe are staggering and could help us solve some of the most perplexing mysteries in physics. One of these mysteries is dark matter. We know it's there because of its gravitational effects on galaxies, but we can't see it or directly detect it. What if this elusive substance is actually in another dimension? We can't interact with it because it's not in our 3-dimensional world, but we can feel its gravitational pull because gravity can reach across dimensions. Another enigma is dark energy, the mysterious force that's accelerating the expansion of the universe. Could this too be a multi-dimensional phenomenon? Some scientists propose that dark energy is actually energy from other dimensions leaking into ours, causing the universe to expand at an accelerating rate. And let's not forget the potential for space travel. If multiple dimensions do exist, then it might be possible to take shortcuts through higher dimensions to travel vast distances in an instant. This is the concept behind a wormhole, a hypothetical tunnel through space-time that could connect distant regions of the universe. However, these are not the only implications. The existence of multiple dimensions could fundamentally change our understanding of reality. It would mean that there is much more to the universe than what we can perceive with our senses and even with our most advanced scientific instruments. Yet, it's important to remember that these are just hypotheses. We don't have definitive proof that multiple dimensions exist, but the mere possibility is exciting and challenges us to expand the horizons of our knowledge. The implications are mind-blowing, aren't they? But remember, these are still hypotheses waiting to be proven. Exploring the concept of multiple dimensions is like embarking on a journey to the unknown. It's an adventure that challenges our understanding of the universe and our place within it. Today, we have navigated through the intricate labyrinth of dimensions, from the familiar 3 spatial dimensions and time to the hypothetical realms that extend beyond our perception. We've grappled with the idea of dimensions as directions in which we can measure or move, and the tantalizing possibility of more dimensions that we cannot directly perceive. We've delved into the hypothesis of multiple dimensions, a concept that emerges from the abstract world of mathematical equations and physical observations, yet remains elusive and mysterious. We've also touched on the profound implications of these extra dimensions. If they do exist, they could potentially revolutionize our understanding of the universe, offering intriguing solutions to enigmas like dark matter and dark energy. The potential for time travel or space travel, although purely speculative, is a captivating thought that stirs our imagination. In this journey, we've learned that curiosity and open-mindedness are vital. Understanding complex concepts like multiple dimensions requires us to question what we think we know, to push the boundaries of our knowledge, and to embrace the unknown. It's a journey that is as thrilling as it is enlightening. For those of you who've joined us on this expedition, we hope you found it as fascinating as we do. There's so much more to discover, so many more questions to ask, and so many more mysteries to unravel. If you enjoyed this journey through multiple dimensions, do not forget to subscribe, like, and share this video with your friends. And of course, leave your thoughts in the comments below. Stay curious and keep exploring.